We're going to go ahead and take a look at a test for a single proportion. Now, we're going to take a look at our hypothesis testing, and we want our sample distribution, assuming the null hypothesis is true. So we're going to assume that our null hypothesis is true. We get our standard error for our distribution to be this. So what do we use in our standard error if we don't know what p is? Well, we're going to use our null hypothesis. Since p equals p naught, we're going to replace these p's with p naught, our null hypothesis. So we can estimate our standard error using our null hypothesis and 1 minus our null hypothesis divided by our sample size, all inside of our square root. Remember, for figuring out our statistic, or our z-score, it's always our statistic minus the null hypothesis over the standard error. So for a proportion, it will be our statistic, which is p hat, minus our null hypothesis over what we were just saying was our standard error. Now, remember, you need to make sure that your counts are basically greater than or equal to 10. Because if it is, it's approximately normal, and we can use our normal distribution then. So consider this situation. We have 2,430 baseball games that were played in 2009. And the home team won 54.9% of the games. So, is there evidence that the home field is really an advantage? That's what we're going to go ahead and do our test on. So, the counts are greater than 10 because you need to have at least 10 that were successes and at least 10 that were failures. If you think back here, you could go ahead and take 2,430 and multiply it by 0.549, and then you could go 2,430 times 1 minus 0.549, and they're each going to be greater than 10. Or you can realize that if you take about 55% of this, it's a lot greater than 10. And if you would take 45% of this, it's a lot greater than 10. So you can consider both of those ways. So we get both of them are greater than 10. So that means we can go ahead and use our idea of normal. Our null hypothesis is that it doesn't make a difference, so it's a 50-50 chance of winning if you're playing at home. Our alternative is that home field advantage does make a difference, so we're thinking that our probability of winning is greater than 50%. To figure out our statistic, we're going to go our p hat, which we knew was 0.549, minus our null hypothesis, which we just said was 0.5, over our standard error. So we're going to take our null hypothesis and put that in for p naught. So it's 0.5 times 1 minus 0.5 over our sample size of 2,430. Work out the bottom, we get about this. Work out the top, we get this. Now we're going to go ahead and divide. We're going to get something very close to this. So if we look at our normal distribution on StatKey, with our mean being 0 and our standard deviation being 1, because remember, z-scores go ahead and give us a mean being 0 and a standard deviation being 1, because this is saying we're 4.86 standard deviations or standard errors from our mean. If we get right tail, we do right tail because it's greater than 0, and we type in our statistic down here in the bottom, and it gives us our p-value right here. Now this is 6.2 times 10 to the negative 7, which means we got to take our decimal point and move it 7 spots to the left. So it's going to be 0.000000062, which is extremely small, really close to 0. So we would make this conclusion that there is strong evidence that home field advantage is a situation in Major League Baseball. Now, we could also go ahead and do that with our randomization distribution, like we've done before with StatKey. And you'll notice we get our p-value when we look at our statistic being 0.000, basically 0, like we had before. So let's go ahead and try those on StatKey. So once again, where'd it go? Here we go. We'll go ahead and go to StatKey. We'll go to theoretical distributions at the bottom. Down here, we're looking at normal. We'll go right tail. We'll go ahead and put in our test statistic, which was 4.86. And you'll notice we get that p-value being really close to 0 because we have to, it's a -7 here. So we have to move our decimal point 7 spots to the right, which gives us 0.6 zeros and then 59. Now, if we're doing this over here, we would do our hypothesis test, single proportion. We go ahead and enter our data. We have to go ahead and figure out what 0.549 times, because that was our percent, times 2,430. That's this. That's how many games were won at home out of a total of 2,430 games. Then we could go ahead and generate 5,000 samples. And then we could go ahead and do our right tail. And we could do our test statistic, which was 0.549. And you notice you get the same p-value of basically 0. So it works out either way. So I just did both ways to help show you that they both work.